All right, I'm going to go over the last two examples out of chapter 10 in section 10.4. It talks about inelastic collisions when kinetic energy is not conserved. This is like the mother lode of questions. This takes into account pretty much everything that we've learned in physics. If we've learned it, I mean, it doesn't have to do with waves, but if we've learned about it in terms of force, in terms of kinetic energy, in terms of momentum, it's all going to be in here, all right? And it's going to take some logical thinking. I can't tell you that every single time you're going to do this or every single time you're going to do that. It's going to take you sitting and trying things to figure it out, which is why I have spent so much time going over, making a list of information. What do I want to know? What can I figure out? So I'm going to take you through these two examples. And then I'm going to get you to try some. We're going to have to put the assignment off. I'm going to now make that due Monday. All right, I'm going to make that due Monday, but you have to get it in on Monday because I have to have marks in for Wednesday. So that means I got to get them marked and get the marks in. So really, really important, if I extend the due date to Monday, that you do have it done and handed in. If you finish it before that and you want to hand it in, I'd really appreciate it. But I want to give time to be sure that you've at least tried a couple of these so that you can do as well as possible on these assignments. Remember, there's no midterm, there's no big unit test for me to put in as a large mark. So I'm going to have to play with those marks a little bit. So again, this is going to take into account everything. So the first example is going to talk about forensics again, and it's going to talk about kind of one of the things that they do in training, and that's talking about figuring out how fast a bullet was going before it hit something. And so it says a forensic expert needs to find the velocity of a bullet fired from a gun in order to predict the trajectory of the bullet. So in order to predict where it's going to go. So he fired a 5.5 gram bullet. So mass of the bullet is 5.5 grams. Into what is called a ballistic pendulum bob. Now they have a picture of it. Let me explain it. I'm going to explain it with just stuff I have laying around my house. So I found a little shower thingy. So think of this is a block of wood and it's hanging down. It's just freely hanging, okay? So they fire the gun. This is not moving. They fire the gun. The bullet comes at it. It hits it, the bullet goes into this and sticks in it. It doesn't go through it. The bullet goes into it and stays there. But because of the impact, this is going to swing, right? Once it hits, it's going to swing up. And so they say he fired the 5.5 gram bullet into that ballistic pendulum. And that pendulum bob, and the pendulum bob just means the piece of wood hanging down that's freely hanging. That's called a bob, not a Bill or a Steve, it's called a bob. Okay, so the pendulum bob has a mass, so I'm going to put P for pendulum, otherwise I have B for bullet and B for bob. That doesn't make any sense, so I'm going to put P for pendulum. It has a mass of 1.75 kilograms. So different units of measurement there. Now, it says the pendulum is swung to a height 12.5 centimeters above its rest position. 12.5 centimeters. So again, what that means is if it started down here, when the bullet hit it, it went 12.5 centimeters higher. It doesn't mean it swung 12.5. It means the difference between where it is now and where it is now, the difference in height up and down is 12.5 centimeters, okay? We're back to your crazy teacher using whatever happens to be sitting around in her classroom / house. It says, what was the velocity of the bullet just before it hit and became embedded in the pendulum bob? So just before, so the bullet's coming at it just before it hits this. How fast is the bullet going? That's what it wants to know. Okay, so we want to know what was the velocity of the bullet just before it hits the pendulum bob. So, so we need to think about a bunch of different things. First off, when the bullet, we're gonna look at the pendulum bob first, okay? We're gonna look at the pendulum bob first, because what we're gonna figure out is we're gonna figure out how fast is this moving when the bullet hits it, okay? So it's not hitting before it hits it, but right after the bullet hits it, how fast is it going? So at the bottom, when the bullet hits it, it is all kinetic energy. It's all movement, and it pushes it up here until it slows down, runs out of energy. So up here, it is all gravitational potential energy because it's not moving for a second, and then gravity starts pulling it back down. Now remember that that energy can't be created or destroyed, just transformed. So the kinetic energy at the bottom of the swing, the kinetic energy when the bullet hits this, has to be equal to the gravitational potential energy at the top of the swing. So once it goes up here, okay? So we know that kinetic energy at the bottom is 1/2 mv squared. We know that gravitational potential at the top is mass times gravity times height. Now we could worry about mass if we want to, but we actually can just cross it off and not even worry about it, because remember, we're talking in this case, we're talking in both at the bottom and the top, we're talking about the bullet and the pendulum both together, because we're saying that it has kinetic energy once the bullet hits it, and then it moves up, and it has gravitational potential energy at the top. So the mass doesn't change from the bottom to the top. The bullet and the pendulum, the bullet and the pendulum. So I don't even need to fill that in. I can just cross those off, which is kind of handy. All right, so I have 1/2 velocity squared is equal to gravity, acceleration due to gravity times height. Now it's 12.5 centimeters. We know that there's 100 centimeters in a meter. You should know that. So that is 0.125 meters. So if I want to solve for V, I'm going to do 9.81 times 0.125. If you want, divide it by 1/2 or multiply by 2, whichever you want. And then because this is V squared, you're going to have to take the square root of it. So if I do that, 9.81 times 0.125 times 2, square root that, gives me, so the velocity of the pendulum and the bullet together, once they hit, is 1.566 meters per second. Okay? So that is the velocity of the pendulum and the bob together. Because what I found out was the difference between the kinetic energy of the two things at the bottom and the kinetic energy of the two things at the top. But I want to know what's the velocity of just the bullet right before they hit. And when we talk about collisions, I said one of the things we look at is we look at the momentum right before, like a millisecond before the collision, And then we look at the momentum directly after the collision, and that has to be conserved. The momentum before has to be equal to the momentum after the collision. So let's look at those things. So before they collide, those are two separate things. There's the bullet and there's the pendulum. So before, we're going to do, for the bullet, we're going to do mass times velocity before. So we've got to change that into kilograms. So that's 1,000, 1, 2, 3, so that's 0.0055 kilograms. And we're actually trying to find the velocity of the bullet before, plus then there's the pendulum. The mass of the pendulum is 1.75, and before the bullet hits it, it's not moving at all. Afterwards, though, we have, so the bullet has hit the pendulum. It's now the bullet's now inside this, so it's now one thing. So the momentum is, there's just one momentum, the two things together. There is the bullet plus the pendulum for mass times the velocity of the two things together, which we figured out was 1.566. So that's gone because that's 0. So now I only have one unknown, and that is the velocity of the bullet. And so if I do that, 0.0055, whoops, 0.0055 plus 1.75, and then I multiply it by 1.566, and then I'll end up dividing it by 0.0055. It's going to end up being 499.8 meters per second. Now we need 3 significant figures, but if I round that off, that's 500, so 5.00 times 10 squared meters per second. And it should be relatively fast. A bullet is going very, very fast. That's kind of the point of a bullet, right? Okay, so that's the first model problem. There's a second model problem with this, and that starts at the bottom of 522 and goes to 523. So again, even in this one, we didn't go straight to the answer. We had some other things we had to figure out first. And again, that's why I make the list. So we have a block. Now, I don't know where they come up with these examples, but anyway. We have a block of wood that has a mass of 0.500 kilograms. So a mass of a block of wood, so we'll call it mass 1, is 0.500 kilograms. All right, it's sliding across the floor. So mass 1 is sliding across the floor toward a 3.5 kilogram block of wood. So mass 2 is 3.5 kilograms, so much bigger. And it's just sitting there minding its own business. Just before the collision, the small block is traveling at 3.15 meters per second. So the velocity of 1 is 3.15 meters per second. And now what they haven't told you up until now is there's actually some nails sticking out of the blocks. So there's like some nails sticking out here and some nails sticking out here, so that when they collide, they stick together. I don't know where they come up with this. The blocks stick together when they collide, and so they kind of slide along the floor, and they make scratch marks on the floor. If my child did this, I'd kill them. And the scratch marks show that they slid a distance of 2.63 centimeters. So when they collided, they slid a distance of 2.63 centimeters before they came finally to a stop. So, what is the coefficient of friction between the blocks of wood and the floor? What's the coefficient of friction? Like, where did that come from? That just came out of the blue, but that's what they want to know. What is the coefficient of friction once these two blocks lock together and start sliding along the floor? What is the coefficient of friction between the floor and the blocks of wood? All right. So, one of the things we need to figure out is once these two lock together and start sliding along the floor, how fast are they going? That would be a good thing to know. So that would have to do with momentum. And again, momentum is conserved before the collision and after the collision. So before the collision, we have mass 1 multiplied by its velocity, plus we have mass 2 multiplied by 0 because it's not moving. Now afterwards they become locked together, so there's only one momentum afterwards, and that is 0.500 plus 3.5 for my mass times my velocity of 1 and 2 together. So when I figure that out, that's gone. My velocity is going to be 0.5 times 3.15 divided by 3.5 plus 0.5. I think I can do that. That's 4. And so the velocity is 0.39375 meters per second. Hopefully I agree with them, and I do. Good. Okay. So we got to think way back now. Remember I said they're going to pull everything in. So energy is conserved. Okay? Energy is conserved when something happens. Energy cannot be created or destroyed, just transformed. Oh, I need to put this over here. Velocity is 0.0, so 39375. Okay, so when the two blocks collide, they only have one kind of energy. They're moving. There's no gravitational potential energy because there's a floor there. So gravity's not really doing anything. It's already at 0. So no gravitational potential energy. No elastic potential energy. So that means that when they collide, it's all kinetic energy, which is 1/2 mv squared. When they collide, it's all kinetic energy. Afterwards, though, they're not moving. They've stopped. So if energy is not created or destroyed, but it's not moving, and there's no gravitational potential energy because it's sitting on the floor, there's no elastic potential energy, and there's no kinetic energy because it's not moving anymore, where did it go? Well, we lost all that energy in the form of heat. We lost it because work was done between the floor and the blocks of wood. So the kinetic energy when they first collide has to equal the work that was done to stop those blocks from sliding. So again, way back in your brain or way back on your formula sheet somewhere, there's a formula for work. And that formula is force times distance. That's your formula for work. So now we're going to start filling some things in here as soon as my dogs stop barking. So we have kinetic energy is 1/2 mv squared. Now force. What kind of force is going on here is force of friction, right? That's what's stopping the blocks, is just friction. So the force that we're talking about is force of friction. So force of friction times distance in this instance. Force of friction is coefficient of friction times normal force times distance. Now normal force, what is my normal force? My normal force is working opposite, right? Normal force is going up that way, working opposite to force of gravity. So my normal force is equal to my force of gravity. So I have 1/2 mv squared on this side is equal to coefficient of friction times normal force, which is the same as force of gravity, times distance. Now, again, if I want, I can fill m in. It would just be the 2 blocks of wood added together, so it would just be 4. But because I have a mass on both sides, it's just as easy to cancel them out. If you forget to cancel them out and you put it in, it's fine because it'll work out. So we have 1/2 times mv, that should be squared. I don't know why I made it a subscript. 1/2 mv squared. So 1/2 v squared, and I already figured out the velocity in the first part of this question was 0.39375 squared. That's equal to the coefficient of friction, which is what I want to know, times acceleration due to gravity, which is 9.81, times the distance. Well, that's 2.63 centimeters, so that is 2, that is 0.0263 meters. So now all I'm missing is my coefficient of friction, which is what I want to know. Now, if it's a coefficient of friction, I know I should get an answer that is relatively low, between 0 and 1, probably closer to 0. Wood on floor, not really, there's going to be quite a bit of friction there. So, well, hello, Wicket. So 0.39375 squared times 0.5 and then divided by 9.81 times 0.0263, I get that my coefficient of friction is 0.30. No units because it's coefficient of friction. There's a dog around my feet, sorry. Now there's a husband around my feet. All right, so you can see that we're pulling in ideas from all through physics. And this example was different from the first one that I did. They are not always going to be the same. You are going to have to figure out what to do. Wicket, come here. Wicket, come here. Come here, buddy. Wicket, come here. I have an injured dog. He hurt his ligament in his leg, so he's on rehab. Poor guy. All right, say hi. I have to do conditioning exercises now. All right, so that's how you do those. I'm going to give you some to do. Again, we're going to make your assignment due on Monday because I think that's only fair. Yeah, we'll see how all this goes. I plan on giving you this. This should be, like, I'm actually recording this on Tuesday, but I'm thinking this will probably get posted on Thursday. So you'll have like Thursday to try and do these questions. I'll have Friday to post help, and then you'll have the weekend to try and finish up your assignment, and then you should have that done. All right, and then after that we'll have to do a test. I would have liked to have had a test on 10.3 and 10.4 into this quarter, but it's just not going to happen. Again, with everything going on, I'm just having to adjust and deal with things in my world. No worries, we'll get there. Your marks shouldn't be bad. The good news is you guys are getting way more done than your public school counterparts. So those of you headed off to university, you won't be behind. That will be good. So I will see you again. I anticipate probably some questions on this stuff. If there isn't, I'm going to be asking you guys about that because I would have questions on this stuff, okay? So we'll talk to you again soon, probably an answer video to this stuff, and really try and do well on that assignment. It's unfortunately, I don't have a lot of different places to disperse your marks over, so just keep that in mind. I am going to make a good portion of your mark things you've handed in. If you've been keeping up online, those types of things are all going to go towards a good mark for you, okay? So we'll talk to you again soon. Bye.